Hello everybody, welcome to the Chapter 5 quiz study video. So I'm going to be going over different types of problems that you will see tomorrow on your quiz. What I suggest you do is when I pull up the page, you write down the problem, pause the video, try it yourself, and then I'll explain. Alright, so let's go ahead and get started. The first type of problem you will see is factoring. So we're looking at problems A and B. Go ahead, write those down, give them a try, and I'm going to go over them now. So in this first one, we don't even have to use our factor box because really what we're trying to figure out is what's going to multiply to 60 but then add to a negative 17x. When we do that, because we've got a coefficient of 1 in front of our x squared, we know that what we're going to have is going to be the quantity x plus or minus something times the quantity x plus or minus something. We can see that we need to get something that when multiplied together will be a positive number, but added together is going to give us a negative. So what that means is we'll have a double negative. Because a negative times a negative is positive, and then if we add our two negatives, we will get a negative number. So for our 60, we can think about the different things that are going to multiply to 60. Those could be things like 2 times 30. 2 and 30 add together to be 32. That's not going to work. We could do 3 and 20 will give us 60. 3 plus 20 is 23. Not quite. Let's see, we could do 4. We're going to have 4 and 15, which gives us 19. So we're getting closer. So my next one then will be 5 and 12. 5 and 12 add together to be 17. So we need a negative 5 and a negative 12. If you're ever unsure, you can always check your work. So we can take and FOIL this out, multiply it. So we'll have x squared minus 5x minus 12x plus 60. And when we combine, we'll get x squared minus 17x plus 60. It's a good way to check our answer. In B we have, when we look at our x squared, we have a coefficient greater than 1. So we might think that we need to go to our factor box. But we want to be careful because we want to make sure that we pull out anything that they all share. So in this case, our greatest common factor is 3. So when I expand it, I'll have 3, and then I'll have x squared plus 4x plus 3. So now what we have is a problem that looks very similar to A, where we'll still have a 3 out in front, but we're going to want x plus or minus something times x plus or minus something. That something being, we've got 3, there's not too much that multiplies to 3, that would be 3 and 1, because it's a prime. So we know that 3 and 1 will give us 4, which is perfect. So we're going to add 3, add 1. And again, we can double check our work. When we do that, we'll get our x squared plus 4x plus 1 times 3. 3x squared plus 12x plus 3. All checks out. So our final answer, you'll need to have that 3 out in front. 3 times the quantity x plus 3 times the quantity x plus 1. Then we're going to move in to our different functions. I'll give you a function f of x and a function g of x. And I want to know a couple things. One being what happens when I add those two things together. And then later on, compositions of functions. So if I'm adding them together, real easy. First, what I want to do with my f of x function is I'm going to want to take and simplify it down so that I can see all the different factors. So we'll have x minus 1 squared is really x squared. Then it would be minus 2x plus 1. And then we take and multiply all of that by 5. So what we really have then is 5x squared minus 10x plus 5. So for our f of x function, we'll write that 5x squared minus 10x plus 5. And then we want to take and add to that my g of x function. So add 2x squared minus x minus 1. And when you add those things together, you want to combine like terms. So I'm going to combine my x squareds to leave me with 7x squared. My middle terms, negative 11x, and then my last one, 5 minus 1 is 4. When we add them together, that's what we get. And that's our final answer. We don't have to solve for x. That's it. Then we do our composition of functions. Remember, we're going to do the inside, then the outside. So first what we want to do is find our g of 10. So we're taking that 10 and plugging it in for wherever we see an x in our g of x function. So we've got 2 times 10 squared minus 10 minus 1. So we should have 200 minus 10 minus 1. So 200 minus 11, we'll be left with 189. We then take that number and plug it into our f of x function. So what we then want to find is f of 189, which is going to be a huge number. So I'm just going to take and plug it in to my unsimplified version. 5 times the quantity 189 minus 1 squared. So I'm going to take 5 times 188 squared, which again will be huge. So 188 squared times 5 is 176,720. Then we have the other way around. One common mistake people will make is that they'll think that these two things have to be equal, but they are not, because order is so important when you're doing compositions. So B and C will have two different answers. What we need to do first is our f of x function, f of 10. So we plug 10 in. 5 times 10 minus 1 squared, or 5 times 9 squared, would be 5 times 81. 5 times 81. 405. And then we take and plug that into our g of x. So g of 405. Which will then end up being 2 times 405 squared minus 405 minus 5. Which again will be another really huge number. With that one, just making sure you understand the process and what we're doing with our compositions of functions. Moving on, we want to decide whether f of x and g of x are equivalent. Usually what these problems hinge on is whether or not you remember the middle term when you simplify it out. So over here, my f of x function, if I were to simplify this, we get 5 times x squared. Our inside term would be minus 10 times 5, so negative 50x, and then minus 5 plus 5. So what's going to happen is these two things will cancel out, and we'll be left with 5x squared minus 50x. On the bottom, they just have a 5x squared. So again, if you had forgotten that middle term, you might think that then these two things would be equivalent, but they are not. Because we've got that value there. The only time that these two would be equivalent is if f of x was f of 0 and g was 0. And even then, our top one would still be 5, and our bottom one would be 0. So looking at this guy, the important part that we realize is that it says for all values of x. And so if we can come up with one example where they are not, so the one I just gave where I plugged in 0, we got the top one to be 5 and the bottom one to be 0, is one example where they are not all equivalent, so it will not work. All right, so then moving on to our next problem. We're given a function. Sorry, I wasn't able to write that as a fraction very well. It's f of x equals 1/2 x squared plus 3. And there's a few things we want to do with it. We want to be able to write the inverse equation, graph the original f of x and graph our inverse equation. That's our f negative 1 of x. And then in C, we want to know, is the inverse a function? So I'm going to do part A and part C on this page, and then I've got a graph for the next one. So for this first one, we want to write the inverse equation. What this really is right here is y equals 1/2 x squared plus 3. Remember that when we rewrite the inverse, we switch our variables out. So we have x is equal to 1/2 y squared plus 3. And then we're going to take and solve for y. So we'll subtract 3 from both sides. So we'll have x minus 3 is equal to 1/2 y squared. Then we want to divide everything by 1/2, which is the same thing as multiplying everything by 2 to get rid of that fraction. So we're left with 2x minus 6 is equal to y squared. And then we want to take and undo the square by taking the square root. It is worth noting that you have to take the square root of this thing as a whole. That's not the square root of 2x and then the square root of negative 6. It's got to be the whole thing. And now remember, with this, we want to have a plus and a minus. So in order to get full credit, the entire answer is that our inverse is equal to plus or minus the square root of 2x minus 6. Then we want to take and we want to graph that. So we want to graph the function and the inverse. So if we're graphing the function, that'll probably be easiest. So if I go over here, I need to rewrite it. My f of x was 1/2 x squared, I think plus 3. Yes. And then my inverse was plus or minus the square root of 2x minus 6. So with our first one, we can make a table, plug some values, and start plotting. I can put in things like -2, 0, 2. So if I do that, 4 squared, or sorry, -2 squared is 4. 4 divided by 2 is 2. This first one is 5. That means this one will be 5 as well. When I plug in 0, we'll get 3. So I can start to plot those points. 0, 1, 2, 3. -2, 5, 2, 5, and it would keep going. So something's true about the table for an inverse function, and it's that it's the opposite. You literally take and you flip it. So we'll have 5, -2, 3, 0, and 5, 2. So I'm going to plot the point 3, 0, 1, 2, 3, 0. And we have 5, -2, and 5, +2. So we have, as it's going like that. And we can see that we have flipped it over our x equals y. So the next part is that they ask us whether or not my inverse is a function. And if you look at the graph, we can clearly see, even in our table, that when we plugged in 5, we got out both a -2 and a +2, which means that there was 2 outputs for 1 input. So that goes against our definition. So no, it violated the definition of a function. Our last problem then is log 1. Hopefully you guys can see how to do this. It takes a minute when you look at it. Just remember the inverse of a log function is your y equals abx. More specifically, we're just looking at the case where y equals bx. And we want to take and solve for x. So for this first one, I'm really asking 2 to the what is equal to 16. And we know that we have to do 2 times 2 is 4, times 2 is 8, times 2 is 16. 1, 2, 3, 4. So we know that x is equal to 4. And the next one, we're asking 10 to the what is equal to 1,000. Well, that would be when x is equal to 3. And C, 5 to the what is equal to 125. Again, that would be x to the third. And then lastly, 10 to the what is equal to 1. And we know that anything raised to the 0 is equal to 1. So x is equal to 0. This is about as complicated as logs will get, so as long as you feel comfortable converting between logs to exponents,